Welcome to the Ask Me Anything session. You have posted a lot of questions about our MOOC and we are really happy to see all these questions. Let's first introduce myself. My name is Peter Hamersma. I'm a professor in transport phenomena at this university. On the left side I have Rob Mudde, which is professor also in transport phenomena, specialized in multi-phase flows. And on my right hand side I have Max van Amsterdam, which is a graduate student at this university. Well, we have received a number of questions and, well, let's start in answering the questions. Let's start with question 1.
Well, Rob, I'm going to ask this question to you, and it's come to us by Lucian, and it is about mathematics. What level of mathematics is required for this MOOC?
Great questions. Thanks very much. I wrote 2 equations on the PowerPoint sheet behind us. And let me explain you what we do with it. I'll go to the board here and write them down. The first question, the one in yellow, reads as written here. This is what we will deal with in the course. It tells that heat is flowing because there is a temperature change along an object. For instance, my pen. Could be warm here and cold on that side, and heat would flow in that direction. That is basically what this part tells us. Temperature difference across the pen, and the length scale is delta x. If you shrink delta x, you arrive mathematically at this one. Here we will deal and talk about the underlying phenomena. The heat flow as it is going. The other one is more advanced, and I'll write it down as well. And I wouldn't be surprised if some of you couldn't read it. This deals with another topic of heat flow. And actually what it says is that if I have an object, a strip of material, and I let flow come in from the left side and heat flow out on the right side, then these two grouped together give you something like this. If there is more flowing from this side than from that side, the object will be heated over time. That is what this part tells. Why do I show you this? Don't be scared of these mathematics. We will not use them extensively. Actually, this one is not even used at all. But we will show you that the underlying principles are in this icon. And it is the icon that tells you how transport phenomena work. And this is understandable without any math. I can think of a heat flow in and a heat flow out. And I can understand that if more heat flows in than out, then the object will heat up. That is the essence of transport phenomena. And we cast it into mathematics if we want to compute. But we will stick to this type of form or even that form, and that should be sufficient for this course. Thanks for the question.
Rob, thanks for your answer. Let's go to the next question.
Well, the next question comes to us by Shivansu, and it's about fluid mechanics in this MOOC. Is it covered?
Okay, thank you, Max. Thank you, Shivansu, for the question, by the way. Well, in this course, we will deal with energy balances, and of course as a result of the energy balances we will have the thermal energy balance and the mechanical energy balance, and we will certainly answer in the mechanical energy aspects of fluid mechanics. Let's say the power of a pump or the pressure over a pipe if some things are known, but also of course Bernoulli's equation, which is found in many fields of fluid flow. But we will not deal with, let's say, complex laminar flows or turbulent flows. So fluid mechanics is not really a part of this course. Okay, thank you for this nice question. Let's go to the next one.
Well, Peter, I got another question for you, also from Shivansu, and it is about radiation. Is that covered in this MOOC?
Okay, thank you. Well, sorry, the answer is quite simple. No, radiation is not dealt in this course. We will not say anything about radiation, but it is an important item, and we will come back to that item in our advanced MOOC on transport phenomena. Thanks for the question. Let's go to the next question.
Well, the fourth question is from Leonardo Silva and is about transport phenomena in civil engineering. can he use concept he will learn in our MOOC to apply in civil engineering?
Hi Leonardo. Yes, you can. We will not deal directly with problems out of civil engineering, but lots of the concept that we talk about will find application in civil engineering. For instance, rivers carry sand-like material, sediment. To understand how that flows and moves in a river or estuary, you need the drag force, and we will talk extensively about the drag force. Another one is Bernoulli's law. Bernoulli's law will help you, for instance, understanding environmental flows, how high and low pressures communicate with slow and fast moving gases and liquids. We will talk about conduction of heat and diffusion of mass. Although they find limited applications in civil engineering, understanding how that works and what the concept is will help you tremendously if you have to think about flow through porous media. Similar type of mathematics apply, similar type of ideas apply. And if you have to work with, say, Darcy's law that governs flow in porous media, and you do understand either diffusion or conduction, or better both, then digging into Darcy's law is relatively straightforward. Final example is diffusion itself. Suppose you have a spill of some kind of pollutant on the ground. Then we will teach you and we will discuss with you how fast that will penetrate, diffuse into the soil. And thus you will be able at the end of the MOOC to estimate whether you need to take action within a day, a week, or that you can wait months. And you will also be able to deal with the question, what if nobody does anything? How deep does it penetrate and how quickly before it reaches the groundwater? Hope that answers the question.
Okay, thank you. Well, let's go to the next question.
Well, we have the last question for you today, and this is also from Leonardo, and I want to ask it to you, Peter. And it is about whether the MOOC relates to any TU Delft course where, for example, I as a student am participating in.
Well, transport phenomena is related to many courses. Rob already told it. In civil engineering you can find a lot of applications. And in fact, transport phenomena is taught in many faculties of our university, in mechanical engineering, in aerospace engineering, and also in chemical engineering. But also in a lot of programs, this course is a compulsory one. You can find it in applied physics, life science and technology, molecular science and technology, earth sciences, sustainable energy technology, and so on. Transport phenomena is also applied in many related courses. Let's say you could think about separation technology or chemical reaction engineering, or in fluid mechanics, of course. So summarizing, yes, this is certainly related to many courses in our university, and it's a really important course. The MOOC is in fact the basis of our course which we teach at our university. The course at our university which we teach to our students is much more advanced. But nevertheless, this course, this basic MOOC in transport phenomena, gives you a little bit the concepts and feeling what you can do with this area. And hopefully this will answer your question, Leonardo, and hopefully we all see you at the 21st of October of this year. Thanks for all your questions and goodbye.